Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to discuss distance, rate, and time, that is d equals r times t, which is something you have to know in order to be successful on the arithmetic reasoning subtest of the Armed Services Vocational Aptitude Battery. More specifically, this video is going to be broken down into two parts, more or less. In the first part of this video, we're going to discuss the distance formula as well as use it to solve some very basic practice problems. After that, we're going to move on to working on some word problems that should closely mirror what you'll see on the ASVAB. In that regard, we're going to start by looking at some very basic practice problems. In my view, anyone should be able to understand how to do these problems. Once we tackle those basic problems, we're going to look at some word problems in which we have two objects traveling toward and away from each other. And again, regardless of your ability level, I think everyone should be able to understand those problems as well. Next to last, we're going to look at some so-called chase problems where we have two objects or people chasing after each other. And in my view, if you're going to score somewhere between 70 and 99 on the ASVAB, you should expect to encounter problems of that nature on the test. And then finally, we're going to look at problems in which you're going to have to use a system of equations to solve a word problem involving distance, rate, and time. Again, if you're going to score somewhere between 70 and 99 on the test, you should absolutely expect to see some of those problems as well. In order to get the most out of this video, I strongly encourage you to make an effort to practice on your own scratch paper at home. That is, after I read a question, you should pause the video, attempt to work it out on your own scratch paper, and then resume playing the video to see if you and I came up with the same answer. On the ASVAB, you're not allowed to use a formula sheet or a calculator. And so in light of that, you're going to have to commit this distance formula to memory. And in addition, you're going to have the ability to do all this arithmetic by hand. So all those things being said, let's go ahead and get started with today's video. To start, we're going to briefly review the definition of distance, rate, and time, and then we're going to do some very simple practice problems. So it says here, for an object moving at a uniform constant rate, the distance traveled, the elapsed time, and the rate are related by the formula d equals r times t, where d stands for distance, r equals rate, and t stands for time. What this says is if you're given at least two parts of these variables in the distance formula, you can find the other one. That is, if you're given rate and time, you can find distance. If you're given distance and rate, you can find time. And if you're given distance and time, you can find rate. So in light of that, let's go ahead and get some practice at doing that. All right, so for A, you can see we have to find D given R and T. So to start, I'm going to simply copy down the distance formula. Again, the distance formula is D equals R times T, where D stands for distance, R stands for rate, and T stands for time. In this case, we don't know what D is, so we'll leave that as is. That said, we know what R is. It's given as 70, so we'll plug 70 in place of R. And we know what T is. It's 5, so we'll plug 5 in place of T. In order to solve for distance, as you can see, all we have to do is multiply 70 by 5. 7 times 5 is 35. Therefore, 70 times 5, we should know, is 350. And as we can see, this is in miles per hour and hours. So we know that this is going to be more specifically 350 miles. Okay. All right, for B, we're still trying to figure out what distance is given a rate of 45 miles per hour and a time of 45 minutes. So to start, I'm going to copy down the distance formula. Again, that's D equals R times T. We don't know what D is, so we're going to leave that as D. We know our rate of speed is 45 miles per hour, so we'll plug in 45 in place of R. That said, we have T, but it's given in minutes. Again, this is given in terms of miles per hour, whereas this is given in terms of minutes. So as you can see, we have a bit of a conflict here. One way to get around that is to rewrite this T, which is given in minutes, in terms of hours. So we can simply plug that into this formula. So again, 45 minutes, when we write it in terms of hours, is going to be this: 45 over 60. Again, there are 60 minutes in an hour. So this will give us the proportion of 45 minutes of an hour. And we should see that 45 and 16 are both divisible by 15. So 45 divided by 15 and 60 divided by 15 are 45 divided by 15 is 3. 60 divided by 15 is 4. In other words, 45 minutes is the same as 3/4 of an hour. Now that we've made that conversion from minutes to hours, we can go ahead and plug this 3/4 into this distance formula and solve for D. Now, at this point, you have a choice. If you like working with fractions, you can plug in 3/4. That said, you should know that 3/4 is the same as 0.75. Okay? Personally, I like working with decimals, doing multiplication. So instead of writing 3/4, I'm going to write in 0.75. So in order to find the distance now, we can see we have to do multiplication of 45 times 0.75. That is, we're multiplying 45, a whole number, by 0.75, which is a decimal. In order to do that, we have to do this: 45 times 0.75, okay? In order to multiply a whole number by a decimal, we're going to have to shift this decimal place 2 times to the right, such that 0.75 becomes 75. And then we're going to rewrite this off to the side, notably 75 times 45, albeit with those 2 decimals to shift back into the left when we're all done working this out. So 5 times 5, as we should know, is 25. So we're going to have to carry a 2 here. 7 times 5 is 35, 36, 37. Before we start multiplication with this 4, we have to drop in a 0 placeholder. 4 times 5, we should know, is 20. Again, we have to carry a 2. 7 times 4 is 28, 29, 30. So let's go ahead and add these. 5 plus 0 is 5. 7 plus 0 is 7. 3 plus 0 is 3. And nothing plus 3 is just 3. Shift in our 2 decimals, 1, 2. And we can see that this distance becomes 33.75 miles. Okay, so again, it's important to be mindful of the fact that your rate and time have to be in the same units. If this is given in miles per hour, your time has to be in terms of hours as well. Okay. All right, for C, you can see we're trying to solve for T in this case, given D as well as R. So let's start by writing down the distance formula. This is distance equals rate times time. We know what D is, so let's plug that in. D is 450. We know our rate is 90. And we know we're trying to solve for T, so we'll leave that as T. In order to solve for T, we're going to divide both sides by 90. In doing so, this is going to cross out over here, leaving you with just T equals 450 divided by 90. You can cross out these corresponding zeros in the numerator as well as the denominator. So this becomes 45 divided by 9. We should know our times tables, and if we did, we know that 45 divided by 9 is simply 5. In mathematics, it's customary to write the variable for which you solved on the left. So this becomes t equals 5. In other words, if you're driving or traveling at a rate of 90 miles an hour, it will take you 5 hours to go 450 miles. Okay, so that was C. All right, for D, you can see that we have distance equals 375 miles, R equals 60 miles per hour, and we're trying to figure out what D or T is. So let's start by writing down the distance formula. Again, that is distance equals rate times time. We know what D is, so let's plug that in. That's 375. We know what R is, so let's plug that in place of, let's plug 60 in place of R. And we're trying to solve for T, so we'll leave that as T. Again, we want to get T by itself, that is, we want to solve for T. So we're going to divide both sides by 60 as our next step. This is going to cross out, leaving us with T on this side. And as we can see, T equals 375 over 60, which is a fraction. Now, just remember, all fractions can be regarded as long division. So 375 over 60 can also be regarded as 375 divided by 60. And by doing this long division, we'll figure out what T is pretty easily. Now we're asking ourselves, as we do this long division, how many times does 60 go into 3? It doesn't. How many times does 60 go into 37? It doesn't. How many times does 60 go into 375 without going over? 60 times 6 will be 360, whereas 60 times 7 will be 420. So we know this is 6 times. 6 times 60, as I mentioned, is 360. And again, you have to get good at doing that mental math. Again, I just regarded this as 6 times 6, which I know is 36, and I tacked on a 0, so 60 times 6 is 360. Now let's do this subtraction here. We have 5 minus 0, which is just 5. We have 7 minus 6, which is 1, and 0 minus 0, which is nothing. Now the question is, how many times does 60 go into 15? It doesn't. We have to tack on a 0 here. In doing so, that's going to prompt us to bring up a decimal point there. So now the question is, how many times does 60 go into 150? We should realize that 60 times 2 is 120. 60 times 3 would be 180. So this is going to be 2. Again, 60 times 2 is 120. 150 minus 120 is 30. Again, now the question is, how many times does 60 go into 30? It doesn't. We have to add a 0. Now the question is, how many times 60 go into 300? That's going to be 5 times. 60 times 5 is 300, so there's no remainder here. In other words, to go 375 miles, if you're traveling at a rate of 60 miles per hour, it's going to take you 6.25 hours. Okay? All right, in these final two questions, you can see we're going to be solving for rate. E says distance equals 400 miles. R is what we're solving for, and T equals 20. So we're going to go ahead and write down the distance formula. Distance equals rate times time. We know what D is. It's 400, so we'll place 400. We'll put 400 in place of D. This is 400 equals rate's what we're trying to solve for. So we'll leave that as R, and T is 20 in this case. So we'll put 20 in place of T. Again, to solve for R, we're just going to divide both sides by 20. This is going to cross out, leaving us with just R on this side. And in this case, R is going to be 400 divided by 20. Before we do this, we can cross out corresponding zeros in the numerator as well as the denominator. So this becomes 40 divided by 2, which we should realize is 20. In other words, in order to go 400 miles in 20 hours, you're traveling at a rate of 20 miles per hour. Okay? And finally, we have F, which gives us D as 12,000 miles. R is unknown, so we're going to be solving for R, and T is, again, 20 hours. So let's start by writing down the distance formula. Again, that's D equals R times T. We know what D is. It's 12,000, so in place of D, we'll plug in 12,000. R is what we're solving for, so we'll just leave that as R. And time, again, is 20 hours. As we did above, we'll divide both sides by 20 to get R by itself. This will cross out, leaving you with just R. And as we can see, R equals 12,000 divided by 20. Since we're running out of space here, let's go ahead and work this one off to the side. That's 12,000 divided by 20. To make this easier, we can cross out a pair of corresponding zeros in the numerator as well as the denominator. So this becomes 1,200 divided by 2. 12 divided by 2 is 6. Tack on those two zeros. 1,200 divided by 2 is 600. So in this case, we can see R is 600. So we know R is going to be 600 miles per hour. Okay. All right. Now that we've done some very simple practice problems, let's go ahead and get started with the word problems. Again, these word problems are going to closely mirror what you'll see on the ASVAB. Question 1 says, on his day off, Lee took a trip to the zoo. He drove an average speed of 65 miles per hour, and it took him 3 hours to get from his house to the zoo. How far is the zoo from his house? So, unlike in the problems above, we have to now identify what the problem's given to us and what we're being asked to solve for. So let's go ahead and do that. We're told he drove at an average speed of 65 miles per hour. So we know 65 is going to be our rate. Moreover, we were told that it took him 3 hours to get from his house to zoo. So those 3 hours are going to be our time. And as we can see, we're being asked to figure out how far the zoo is from his house. So in other words, we want to know what that distance is. So now that we've identified what we were given in this word problem, as well as what we need to solve for, let's go ahead and do so. Again, these are basic word problems, so we know we're just going to be using the distance formula as it is. So let's plug in what we have. Again, we know R is 65, so let's plug in 65 in place of R. We know time is 3 hours, so let's plug in 3 in place of T. And we know we're being asked to solve for D, so let's leave D as is. As we can see, to figure out distance in this case, we're going to have to multiply 65 times 3. So this is going to be distance equals 65 times 3. Let's work that off to the side. 5 times 3 is 15, carry your 1. 6 times 3 is 18, plus 1 is 19. So this is going to be 195 miles. In other words, he lives 195 miles from the zoo. So let's move on to number 2. It says, after work, Janae walked in her neighborhood for a half an hour. She walked 1.5 miles in total. What was her average speed in miles per hour? So let's start by identifying what this problem gives us, as well as what we're being asked to solve for. It says she walked for a half an hour, so we know that's going to be our T for time. Moreover, we know she walked 1.5 miles in total, so that's going to be our distance. And in addition, we can see that we're being asked to solve for her average speed in miles per hour, so that's going to be our R. We want to figure out how fast she walked that distance given that time. So again, we're going to start by writing down the distance formula. Let's plug in what we have. We have distance, 1.5 miles, so that's 1.5. We're trying to figure out what her average speed is, or what R is, so we're going to leave that as R. And we're told that she walked for half an hour, okay? So again, half an hour is the same as 30 minutes. That said, we're being asked to solve for speed in miles per hour. So we have to write this 30 minutes in terms of hours. 30 minutes is the same as half an hour, which is the same as 0.5 of an hour. In this case, we can see we have 1.5 as the distance. So I'm going to use 0.5 of an hour to represent this half an hour. So I'm going to plug in 0.5 right here. All right, so as my next step, I'm going to solve for r. And in order to do so, I'm going to divide both sides by 0.5. This is going to cross out, leaving me with just r on this side. And as we can see, r equals 1.5 divided by 0.5. So let's do that work off to the side. We have 1.5 divided by 0.5. That is, we have a decimal, notably 1.5, divided by a decimal, notably 0.5. In order to do division involving decimals, you have to ensure that this number outside the division bracket is not a decimal. And to do that, you have to shift its decimal accordingly. So in other words, this 0.5 cannot be a decimal for us to do this long division. So I'm going to have to shift its decimal place one time to make 0.55. And what I do outside the division bracket, I'm going to have to come inside the division bracket and do it a corresponding number of times. So instead of being 1.5 divided by 0.5, I'm actually working this out. 15 divided by 5. 5 goes into 15 3 times, given that 5 times 3 is 15, so we can see there's no remainder. In other words, our rate is going to be 3 miles per hour. Again, in math, it's customary to write the variable for which you solved on the left. So this is r equals 3 miles per hour. Okay? All right, for number 3, you can see it says, scientists observed that an asteroid travels 300,000 miles toward Earth in 4 hours. How fast is the asteroid traveling? So in this case, let's identify what we're given in this question. And in addition, we'll take a look at what we're being asked to solve for. We're told it travels 300,000 miles. So we know that's our distance. We know it travels in 4 hours, that distance in 4 hours. So that's going to be our time. We want to know how fast it's traveling, so that's going to be our rate. So let's go ahead and write down the distance formula. And now let's plug in what we have. Distance is 300,000. Rate is what we're being asked to solve for, so we'll leave that as r. And time is 4 hours, so we'll plug in 4 in place of t. Now let's divide both sides by 4 to get r by itself. This is going to cross out, leaving you with just r on this side. And as we can see, this is 300,000 divided by 4. Let's go ahead and work this off to the side. Again, that's 300,000 divided by 4. Now we're asking ourselves, how many times does 4 go into 3? It doesn't. How many times does 4 go into 30? That's going to be 7 times, given that 7 times 4 is 28. 28 minus 30 is 2. And then we have to drop down all of these zeros here. So there's 1, 2, 3, 4. Now the question is, how many times does 4 go into 20,000? Well, 4 times 5 will give you 20. And then if we just tack on those 3 zeros, we'll know that 4 times 5,000 will give you 20,000. So we can see that there's going to be no remainder. In other words, this asteroid is traveling at 75,000 miles per hour. And in math, it's customary to write the variable for which you solved on the right. So that's r equals 75,000 miles per hour. Okay, so that was that one. All right, for question 4, You can see it says train A traveling 70 miles per hour leaves Tallahassee at 5 p.m. and heading toward Panama City Beach, 260 miles away. At the same time, train B traveling 60 miles per hour leaves Panama City Beach heading toward Tallahassee. When did the two trains meet? Okay, so for these types of problems, we should realize that we have all the elements of the distance formula, that is d equals rt. But that said, we have this scenario in which two trains are traveling toward each other, albeit at varying rates. Train A, as we can see, is going 70 miles per hour, whereas train B is traveling at 60 miles per hour. In order to make sense of this problem, it's usually best to draw a little diagram. So let's go ahead and think about what we're doing here. Let's say this is the 260 miles between Tallahassee and Panama City Beach. So let's call this one Tallahassee over here, and let's call this Panama City Beach over here. We know train A is heading from Tallahassee to Panama City Beach at a rate of 70 miles per hour. So if this is train A, we know it's going this direction at a rate of 70 miles per hour. And likewise, we know that train B is in Panama City Beach going towards Tallahassee, albeit at 60 miles per hour. The question is, at what time will they meet? In other words, how long is it going to take these two trains to cover this 260 miles? The easiest way to solve these problems is to think about it this way. Imagine if you had one train, let's call it train C, and it was going the same 260 miles, okay? But it was going at the combined rate of both train B and train A. So in other words, it was going 260 miles, albeit at 70 plus 60 miles per hour. 70 plus 60, we should realize, is going to be 130 miles per hour. So in other words, this train is going the same 260 miles, albeit at a combined rate of train A and B that is 130 miles per hour. These two problems, it turns out, are identical. Okay, in this case, it's very tricky to solve this one using algebra because you have two trains going different rates of speed over the same distance. But if you combine their rates of speed and regard it as a third train going the same distance at the combined rate, this is very easy to do because take a look. We have our distance. We know that's 260 miles. We have our rate. We know that's 130 miles per hour. All we have to do is solve for time in this case. Okay, so that's what we're going to do. We're going to use this second diagram, which we used the first diagram to create, to solve for t. So again, we're using the distance formula. That is distance equals rate times time. We know distance is going to be 260 miles, so let's plug that in place of d. We know our rate is going to be the combined rate of train A and B. That is, it's going to be 130 miles per hour. And we know we're interested in solving for time. So in this case, all we have to do is divide both sides by 130 to get t by itself. This will cross out, leaving us with just t on this side. We could cross out these corresponding zeros, which makes this 26 divided by 13, which is just 2. In math, it's customary to write the variable for which you solved on the left, so this is t equals 2. In other words, t equals 2 hours. In other words, it takes these two trains 2 hours to meet in the middle. And in this case, we're told that the trains leave at 5 p.m. We want to know when they meet. So if they leave at 5 p.m. and they meet 2 hours later, that's 5, 6, 7 p.m. So they'll meet at 7 p.m. to answer this question. Okay, so that's That's how you deal with problems where you have two objects, trains in this case, traveling toward each other, albeit at different speeds. Pretty simple. All right, so for number 5, it says if the bus is traveling at 50 miles per hour and the car is traveling at 55 miles per hour, how many hours will they be, in how many hours will they be 210 miles apart? So again, just like above, we have two objects. In this case, they're traveling away from each other. And we want to know how many hours it's going to take them to be 210 miles apart. So as we did above, it's going to be easy to make a diagram. We know they're both starting at the same point. So let's say this is the bus and this is the car. We know the car is traveling this direction at 55 miles per hour. And we know the bus is traveling in the opposite direction at 50 miles per hour. We want to know how long it's going to take them to go 210 miles. Again, as we did above, it's easier to think about this by combining their rates of speed. So let's say we had this third thing. Let's call it another car. Let's say this was car D. And it went those same 210 miles, albeit at a combined rate of 50 plus 55 miles per hour. That is 105 miles per hour. Again, this scenario, algebraically speaking, is the same as this one. So in light of that, I'm going to use this diagram to solve this problem, given that I know what my distance is. Distance is 210. My rate is 105. And in light of that, I'm just solving for t. Okay, so again, I created a diagram to illustrate what was going on in the problem. Then I just created this third diagram that combined the rates of the two, of the car and the bus, that's going the same distance. And that's going to help us solve the problem very quickly. So again, we're using the distance formula to solve this one. It's distance equals rate times time. We know distance is 210. We know rate in this case is going to be 105. And we know time is what we're solving for. So to do that, we're going to divide both sides by 105. This is going to cross out, leaving us with just t. 210 divided by 105 is going to be 2. Again, in math, it's customary to write the variable for which you solved on the left. So t equals 2. In other words, t is 2 hours, which means that it would take this bus and this car, if they're traveling in opposite directions, 2 hours to be 210 miles apart. Okay, so again, regardless of whether you're solving for objects that are going toward each other or away from each other, just be mindful of the fact that you're going to have to illustrate that with a diagram, combine the rates of speed, and travel the same distance with the combined rate of speed, which will enable you to plug those values into the distance formula and solve these fairly quickly and easily. All right, question 8 says, passenger jet took 3 hours to fly 1,800 miles in the direction of the jet stream. The return trip against the jet stream took 4 hours. What was the jet speed in still air and the jet stream speed? Okay, so right away, you should know that you're dealing with a system of equations because you're being asked to solve for two different variables. We're being asked to solve, in this case, for the jet speed in still air, that's one variable, as well as the speed of the jet stream, that's the other variable. So just bear in mind that whenever you're being asked to solve for two things at once, you're going to need to use a system of equations to do so. That said, we're going to have to use some common sense to figure out how we're going to set this problem up. So we're told that we have some jet, which I'm going to draw like this, traveling with and against the jet stream. So let's go ahead and make two little sketches. In this case, let's say the jet is going with the jet stream. So it's going this way. We know it traveled 1,800 miles. And moreover, we know it took 3 hours to cover that distance. And by the same token, we know what a jet stream does. A jet stream actually is like a wave in that it speeds up how fast a plane can travel. So in this case, we know the rate of this plane is being sped up by this jet stream. So I'm going to represent the rate of this plane as r plus j. That is, its rate of speed is being increased with the aid of this jet stream, which is pushing it like a wave. In this case, we know the jet is now returning back home, so it's going the same 1,800 miles. That said, we know it took 4 hours for it to complete the journey, and moreover, we know now it's going against this jet stream, which is making its speed slow down. Okay, so in order to illustrate this, I'm going to say the rate of the speed of this jet is being slowed down by the jet stream in this case. So that's going to be r minus j, where j refers to the speed of the jet stream. Okay, so now we can use the distance formula as well as these two scenarios, which I just illustrated for you, to set up a system of equations to solve this problem. Again, this is one of the most complex problems you'll probably see on the ASVAB. So let's think about how we're going to do this. Again, as I did above, I'm going to take this distance formula, which is distance equals rate times time, and I'm going to rewrite it like this. Rate times time equals distance. And as I did above, I'm going to use a chart to organize my work, since we have two scenarios going on here, and that can be a lot to keep track of. So let's go ahead and, again, make a little chart. Again, as I said, we're going to call this one R, T, and D right here. Let's make this top row be with the jet stream, and this bottom row is going to be against the jet stream. Okay, so with the jet stream, we know the plane took 3 hours, so we know our time's going to be 3 to go 1,800 miles. And similarly, we represented its rate as r plus j. That is, the jet stream was speeding the rate of this plane up, the rate of speed of this plane up. In this second scenario, we know we went the same 1,800 miles. We know the time was now 4 hours. And again, since the jet stream was pushing against this plane during this trip, we represented its rate of speed as r minus j. Okay, let me go ahead and scroll down a little bit so we can have some more room. And now we've set up almost a system of equations to solve this one. Let me go ahead and get rid of our illustration here so we can have some room to work with. We don't need that anymore. Now that we've got these scenarios written into equations over here, almost. So again, we're doing r times t equals d. So let's go ahead and do that. R times t is r plus j times 3 equals 1,800. Again, that's r times t equals d. And let me write that over here. R times t. Here's our d. This is the first scenario. Now we have r minus j times 4 equals the same 1,800. Again, that's r times t equals d. At this point, we have a few options. As you can imagine, we want to make an effort to simplify these problems as much as possible before we start doing the algebra required to solve them. So in that case, I'm going to divide this side and this side by 3. Of course, this is going to prompt this 3 to cross out over here, which is just going to leave you with r plus j. which is nice and easy. And then we have 1800 divided by 3, which we should be able to do mentally. 18 divided by 3 is 6. Therefore, 1800 divided by 3 is 600. Okay, I'm going to do the same thing in this bottom equation to simplify it. In this case, 4 is going to cross out on this side, leaving you with r minus j equals 1800 divided by 4. That one's not as easy to figure out mentally, so we can go ahead and work it off to the side. Again, this is the same as doing 1800 divided by 4, which looks like this. 4 goes into 18 4 times without going over. 4 times 4 is 16. 18 minus 16 is going to be 2. Drop down those 2 zeros. 4 goes into 25 times. Therefore, 4 goes into 250 times. 4 times 50 is 200, so we can see there's no remainder there. In other words, 1800 divided by 4 is 450. Okay? Finally, we can see that right here, we have our system of equations, which we can now use to solve for r and j. And there's a couple ways we can do that. And let's go ahead and rewrite those down here just so we can have some space to work with. We have r plus j equals 1600. R minus j equals 450. Again, this is our system of equations. In a system of equations, you want to try to eliminate one of the variables such that you can solve for the other variable. In this case, if I simply take this bottom equation and add it to this top equation, you can see that that variable j will disappear. So let's go ahead and do that. Again, we're going to take this top equation. We're going to add this bottom equation to it. And let's go ahead and do that. R plus R is 2R. J plus J is nothing. And this becomes 600 plus 450, which is the same as 1050. Let's divide both sides by 2 now to get R by itself. This becomes R equals 1050 divided by 2, which we should be able to do in our head. 10 divided by 2 is 5. 50 divided by 2 is 25. So as we can see, this R refers to the rate of the jet traveling in still air. So we've answered this first part of this question. R is 525. So the speed of the jet in still air is 525 miles per hour. In order to find the rate of the jet stream, we can take this R and plug it into either of these two equations and solve accordingly. I'm going to take this R and plug it into this top equation here, which will enable me to easily solve for J. So let's go ahead and do that. Again, we have R plus J equals 600. Let's plug in 525 in place of R. So this is 5. My pen's starting to act up, given that this video is getting a little long. This is 525 plus J equals 600. Let's subtract 525 from both sides. This will cross out, leaving you with J equals 600 minus 525, which is just going to be 75. So in other words, the speed of the jet is 525 miles per hour in still air, whereas the speed of the jet stream itself is 75 miles per hour. Okay, so as you saw, we used a diagram, a chart, and a system of equations in order to solve this one. Again, this is one of the hardest problems you'll see on the ASVAB. If you're going to score in category 1, which is between 93 and 99, you will see a problem like this, guaranteed. So make sure to know how to do these. So that's it for today's video. I hope you found it helpful. I covered a lot of ground in this video. Again, I started by giving you an overview of the distance formula. Then we worked on some very simple problems. And after that, we took a look at a wide range of word problems, including some very easy ones as well as some very challenging ones, to say the least. If you like the content I'm creating, by all means, go ahead and subscribe to my channel. That's always helpful. In addition, you're more than welcome to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.
Konnichiwa.